State the y-intercept and zeros of each function. Shh. So I just said the zeros are also the x-intercepts, right? So that's what they're talking about there. If there is no real zero, state so. So if it doesn't have any x-intercepts, we'll just say no real zero. That's what they want us to put. So on number 1, the first question, what is the y-intercept? So where is it hitting the y-axis at? No, that's the x-axis. 6. So what they put is, they were a little more specific. They didn't just put 6, they put 0, 6. Any questions on where that came from? That's where it's hitting the y-axis at. Okay, where is it hitting the x-axis at? -4 to the left and 6. Okay, for this one they didn't put it in coordinates. They just put -4, 6. X equals. Yeah, it's easier to write it that way anyway. That is where the graph is crossing the x-axis at x equals -4 and x equals 6. That's basically the x-intercepts. Number 3, where is it crossing the y-axis? 0, 2. And what are the x-intercepts? So they want us to put no real zeros.
This makes sense.
What if one of the zeros is 0?
Well, it's just put x equals 0.
Okay.
Very wise.
Okay, number 5. Find the zeros of each function algebraically. If there is no real zero, state so. Well, this is like the first thing I talked about. What does this mean, find the zeros?
Solve the equation.
For
0.
So what it means is you make the function equal 0 and then solve it, just like last chapter. What are our options for solving? Factoring. And if you're not good at factoring, quadratic formula. And not every problem factors, by the way. Some of them you have to use quadratic formula. I'll put it back up here since, we're done with that test.
B plus negative b plus or minus b square root minus square root times a times c.
Almost everybody got that right on the test.
Wait, who didn't?
I'm going to have to call out names.
Everybody. Call them out in front of everybody.
Hey, got it right.
Okay, anyways, number 5, it does factor, because what goes into -14? -7 and 2. That adds up to -5. Yeah, -7 and +2. But remember, after you factor, that's not the answer exactly. You have to say what x values make this equal to 0. 7 and -2. So really this is kind of like a review from last chapter, this part.
Well, shoot.
Now, if we're graphing it, which we're going to do later, those would be the x-intercepts if we were graphing. Number 7, -3x squared plus 5x plus 2.
Wait, what?
I'm just writing it down. Equals 0.
You said for 5 through 12 we can use factoring or the
Quadratic formula. This one does actually factor. You guys want to try that or the other one? No, I'm going to factor. It takes less time when you know how to do it. So what goes into 3x squared or -3x squared? I could have multiplied both sides by -1. That might have made it easier. Yeah, I'd probably better do that. It'll be less confusing. I multiplied by -1. It's usually better if your front term is positive. So what goes into 3x squared is 3x times x. What goes into -2? Negative 2 and 1. We want a negative 5 when we FOIL, so if you put a negative 2 out there, that's negative 6. And then the 1 in here, we get to negative 5. You guys remember that stuff? So what x values would make this equal to 0? Positive 2 or negative 1/3. Number 9, x squared minus x plus 8. Wait, I think I did that backwards. Minus x plus 8 equals 0. Does this factor anything multiplying to 8 that adds up to negative 1? The only thing that goes into 8 is like 4 and 2, 8 and 1. Do those add up to negative 1? No. So this does not factor, which means what? Quadratic formula. A, B, C. Negative b plus or minus square root of b squared minus 4ac over 2a. Alright, I got negative 31 in the square root. What does that tell us?
It's not a real number.
Okay, which means there are no zeros, no real zeros. So we don't actually have to like simplify this or anything. If you get an imaginary, just put no real zeros. Now, if it had been positive square root of 31, that would have been the answer. We just leave that as the answer. But since it's negative, there's not really an answer. Could be imaginary. 11. Does 11 factor? Ooh. Well, we don't want to factor 11. Yeah, we want to use the square root trick to solve this. Well, that's the easiest way to do it. You could like do x plus 1 times x plus 1 and like FOIL that all out and try factoring. Since this is squared, I would just try to get it by itself and use the square root trick. You guys remember this? We'll see if you do. So just get x plus 1 squared by itself, and then what did we do? Square root it, yeah, square root it. That gets rid of the square. What did I do wrong?
Plus or minus.
What in the?
Look over for 1 second.
When you use the square root trick, you have to use plus or minus. That's my last step.
You have to add 1 to both of them.
So it's 4 minus 1 and it's negative 4 minus 1.
So 5 and
4 minus 1 is 3. Negative 4 minus 1 is negative 5.
Why didn't, okay, so wait, what was that?
It's 4 minus 1 and negative 4 minus 1.
Yeah, but why don't we do that in non-normal square root?
We already did the square root. Square root of 16 is 4. Square root of 16 is 4.
Where did you start? That's what I'm confused
That's 16.
about. Okay. So we didn't use the quadratic formula?
No.
Okay.
It would have taken quite a bit of work to find out A, B, and C with the quadratic
So that was
formula.
just faster.
Yeah, much faster. You'd have to multiply the x plus 1 times x plus 1 like a FOIL problem. So on 12 it's pretty similar. You want to add 5, divide by 2, then take the square root, then add 1. 12 is kind of a mess, to be honest.
Did you help
Guys,
us with 12?
If you ask me tomorrow, I'll help you. Maybe.
Could I ask you in advance?
Man.
Oh.
Okay, 13 is graph. Okay, what's different about 13?
plus
It's a greater than less than problem. What did we do? It's been a while since we've done these. What changed on the graphs when we had greater than or less than? You shade. Shading, that's what changed. Okay. Let me go to my graph paper. Now, normally when we graphed, I had you guys like plug in some x value, like find the vertex and plug in some x values, right? Do you guys know where the vertex is going to be on 13? Minus 2, negative 2. 2 down.
It's gonna be 5.
So here's what I want you to do. Now minus 2 moves the vertex down 2, so I know there's a dot right there. So guess what else I want you to do? Plug in what? A couple more, just like we did last week. And what are we plugging into? X squared minus 2. Y is greater than. So if I plug in 1 squared minus 2 is negative 1. 2 squared minus 2 is 2. So 1, negative 1, 2, 2. And then I'm going to draw the mirror image over here. Okay, you guys might have forgot. The next part.
You shade in the
Hold on, you skipped something. Is the line solid or dashed? Dashed. How? Why is it dashed?
Because
Because it's greater than, not equal to. What does dashing the line represent?
It's not equal
it's
to
not included.
Any points on that line are not a part of the solution. That's what it means. Okay, it's y is greater than. Should we shade above or below? Above. So that would kind of look like inside in this case. Don't have any fun with those.
Drowsy at Senior Georgia.
That's Spanish.
They know that.
Thank you. Then he said, welcome. In English, of course. Yeah.
Alright, are you guys done with that one? Can I scroll?
Yes, I believe you can.
Okay, 15. Alright, they're kind of nice to us on 14, 15, and 16. These are in vertex form. You guys remember vertex form from Friday? Where is the vertex going to be for number 15? 2, negative 1. You guys see where she got that from? Okay, so that'll be my first point. What other x values might I plug in if...
1 and 0.
Okay, yeah. 2, I could plug in 3 and 4, or 1 and 0, just something close to 2. Okay, where am I plugging in? 1/2 x minus 2 squared minus 1. Okay, if I plug in 1, I get negative 1 squared is 1, times 1/2 is 1/2, minus 1, negative 1/2. If I plug in 0, I get 0 squared is 0, or sorry, 0 minus 2 is negative 2 squared is 4. 1/2 of 4 is 2, minus 1, 1. Alright, so 2, negative 1 is my vertex. 1, negative 1/2, 0, 1. this one's going up a little bit slower. Why is it going slower?
Shell.
We did this 1/2.
Because of the 1/2.
Mr. Jordan, did you know it's supposed to snow today?
Oh, barely, if anything. Yeah, if we lived in like the very western Oklahoma, they might be out of school today.
Mr. Jordan, I forgot something. It's supposed to be a dotted line.
Oh, is it? I was about to look at that. Okay,
Oh my god.
Oh my goodness.
Oh my gosh.
Good one, Trevor.
look, it never happened.
I thought I was gonna look really stupid when it wasn't supposed to be a dotted line.
No, but you did it. You were a genius.
Are you kidding me?
Are
Okay,
you serious right now?
this is it's a greater than, so it's just like 13. So shading above again.
Of course.
Okay. All right, you guys ready for 17? Done with that?
Yeah.
Okay, 17 says find the y and x intercepts of the function, and then we're going to use those to graph the function. So, how do we find the y-intercept? We haven't talked about that yet today.
Plug in the x as 0.
Yeah. Y-intercepts, wherever it's crossing the y-axis, like if it was right there, that would be at 0, 3. Or if it was right there, that'd be 0, 2. All y-intercepts have an x value of 0. So to find the y-intercept, you need to put 0 in for x. So, copying down number 17 says g of x equals, or y equals x squared plus 5x plus 6. So to find the y-intercept, I'm going to put in 0 for the x value. So I get 0 plus 0 plus 6. So 0, 6 is the y-intercept. Now how did I find the x-intercepts?
Y is 0.
Yeah, turn y into 0. So x squared plus 5x equals 0, and solve that for x. So what multiplies into 6 that adds up to 5? 3 and 2. So x equals -3 or -2.
There's so much math.
Okay, notice 17 is not an inequality, so we don't have to worry about the shading and stuff. Just gonna graph. So I'm gonna graph those 3 points. 0, 6. Let me move this down a little bit. 1, 2, 3, 4, 5, 6. And then the zeros of the function are the x-intercepts, -3 and -2.
What if you're counting by?
Wait.
-3, -2. So x-intercepts, the zeros of the function. Do you guys know where the vertex was probably about?
-2.5.
Well, it's gonna have to be here, because
Yeah.
it can't be going down, because then it would never hit that. It must be going up. So it must be about right there. That look pretty bad. I'm gonna try again. There we go. Doesn't have to be perfect. As long as you hit those 3 points, we'll say it's good.
Let's get done with 19.
Okay, last one. I guess I'll go sideways here. 19. -4x squared minus 4x plus 3.
Okay, wait, I have a question, Mr. Ryan. Why do you just completely disregard the fx equals? It's basically why.
F of x is just the title of the function. It doesn't do anything. And
So it
it,
just means why.
it's the same thing as y.
Okay, so why didn't they just put?
Sometimes they'll call the the y-axis the f of x-axis. It's just interchangeable. It's easier to write y than f of x.
But why do you need fx? Why do
It's just a different kind of notation. Sometimes it's useful for different things. Okay, so do you guys remember how I found the y-intercept last time? Put 0 in for x, so that'd be 0, 0 plus 3, so 0, 3. It's kind of easy to find the y-intercept because it's easy to plug in a 0. All right. To find the zeros of the function, or the x-intercepts, I need to set that equal to 0. Does it factor 6 and 2? Yeah, it does factor. I'm going to multiply both sides by -1 to get rid of that negative there. Okay, so what goes into 4x squared? It's either 4 and 1 or 2 and 2. What would you guys guess?
What's good to
2 and 2. What goes into -3?
One and -3 or -1.
Yeah, so it's a positive 4 that I'm going for, so I probably want the 3 to be positive. Right, and then the 1 to be negative. So the inside is 6, the outside is -2, that adds up to 4. So it's
Negative 2 and then,
You should do it. What's your favorite food place in town?
okay, so on the graph, the y-intercept is 3. Check. Where is -3 halves for the x-intercept? -1.5, right? So it'll be right there, and 1/2 is right there. Where must the vertex be to hit all 3 of these points?
Up there.
Probably, well, it's got to be like right between these 2, right? And it's got to go through this, so it's probably like right there. Just a ballpark guess. Something like that. It's going down because there's a negative on the 4x squared. It's going down quickly because there's a 4 on the x squared. Why are you hitting yourself? Why are you hitting yourself?
Could you multiply the entire thing?
Hmm?
For 20, could you multiply the entire thing by